In this video, we're going to solve some problems involving percents. Now in the first problem, John received a 5% raise to a salary of $30,000. What is his new salary? So first off, we have to figure out what the amount of his raise was. To do that, we can take 30,000 and multiply it by 5%. Now 5% is a decimal, is 0.05. In multiplying this out, if we multiply by 5, we get 150,000, but we have two decimal places we have to account for. So his raise is 1,500. Now to get his new salary, we just have to add that to his old salary. That gives us a new salary of $31,500. Now we could have done this in one step. The reason being, $31,500, it's 5% more than his last salary, but it's 105% of his old salary. So what we can do to kind of skip that two-step process is we take the 30,000 and we're going to multiply it by 1.05. Why 1.05? Well, the 0.05 represents the 5% raise, and the 1 represents the 100% of his original salary. So what we're going to find is 105% of his original salary. If you do this multiplication, you're going to see that you get the same answer we had before, 31,500, and there's John's new salary. Now, let's look at the next problem. Mary bought a sweater that had been marked down by 20% for $20. What was the original price of the sweater? Again, there's a couple different ways that we can go about this one. I'm going to show you one using a variable. Now, we know that the original cost of her sweater is what we're looking for. So let's call that X. So X is going to be the original price. Now let's think about how we would do this problem if we knew the original price. We would take the original price and then we would subtract off 20% of the original price. We know how to do that from the first problem. 20% of the original price is 0.2 because we have to move that decimal point 2 places, times the original price, which we're calling X. So this is the original price minus the 20% discount. Had better be equal to $20. Alright. Now, we can combine like terms here because we have X minus 0.2X. So we can think of that as 1X minus 0.2X. So 1 minus 0.2 is 0.8. So what we get is 0.8X equals 20. So we end up dividing both sides by 0.8. Now if we do this, what you're going to get is X equals, okay, so if we want to look at dividing by a decimal for a little bit of practice, we have 20 divided by 0.8. Now we want to move that decimal point, so we move that decimal point there. Now 8 goes into 20 not evenly, but it does go in twice, which gives us 16. Leaves us with 45. So X equals 25, so $25 is the original price. Let's take a look at one more problem dealing with percents. Target just marked down a pair of shorts from $20 to $15. By what percent did they mark down the item? Alright, so what we need to look for is the percentage marked down. We can use what we found out in this problem in order to solve this problem. So let's go back up to this problem. We saw if we took off 20% that we ended up calculating 80%. So 80% of the original price was $20. So we're going to set up something similar here. This time we know the original price, but we need to find what percent of 20 is 15. So X will be what percent of 20 is 15. So we divide both sides by 20, and we're going to get X equals 3/4 or 0.75, which is 75%. Now that's not the percent markdown. What this tells us is that $15 is 75% of $20. But this will help us find how much it was marked down, because $20 was 100%, and it goes down by 25% to get to 75. So, because 100 minus 75 is 25, so we have a 25% markdown. And that's how we can do that.